Hello, and welcome to the Google Ads API webinar on error handling, retry, and timeouts. My name is Andrew Burke, and I'm a developer relations engineer based in the New York office. A couple of quick notes before we get started. You should see a link at the top of the screen to a question and answer service. Please submit any questions that you may have at any time, and if you see a question that you're also interested in, please feel free to upvote it to increase its visibility. We have engineers standing by to answer these questions at the end of the presentation. While not hard prerequisites, we recommend that you have a little familiarity with the API before viewing this webinar. We hope you've had a chance to peruse the documentation for Google Ads API and that you've been able to successfully install and configure one of the client libraries. Of particular note for this webinar, the most pertinent examples are found in the error handling directory of each library's examples. Also note that this particular webinar only concerns error handling with the client libraries, but do note that Google Ads API does support a REST interface as well. We encourage you to check our developer site, more on that in a minute, for documentation on that. Quick step through our agenda. First, we'll take a look at exactly that developer site I just mentioned. We'll then launch into a discussion about error handling, looking at the basic types of errors and how to read them. We'll then cover partial failures, retry, and timeouts, and wrap up with some key takeaways. At the end, as I said, we'll have our Q&A session, and please be sure to share your questions via the link above. First, let's just go over one thing. We're going to be referring to the Google Ads API dev site throughout this webinar. This is the official documentation for the API, and I just want to call attention to a couple of its sections that will be most relevant. Across the top of the start page, you'll see several tabs. For our purposes today, we're only interested in a couple of specific pages. Most of the material that we'll cover today can be found on the Guides tab, under Best Practices, Error Types. The documentation for all errors can be found in the Reference tab. Then expand the version you're interested in, and then go to the Errors category. On each error page listed here, you'll see a listing and description of all the potential errors under that listing. We'll discuss how our errors are organized in more detail later. Lastly, you may also be interested in the Services category page. If we choose a service, like let's say Ad Group Service right down here, we'll use this extensively today. Each service lists the type of errors that it's known to throw. This can be a convenient way to find the correct reference if you've encountered an error as you're developing your implementation. Okay, to start our discussion of error handling, the general idea is that most errors returned by the API can be handled like a normal exception. An error indicates that there's been a problem with a single operation. Google Ads API will also allow you to bundle multiple operations together in a single request. If you choose to do that, then handling with partial failures is the way to go, and we'll talk about those later. Some general notes to help you make the best use of your debugging process as you're developing with our API. We recommend that you turn on detailed error logging, which is different for each library. So do please check the guides to see how to enable that. We also ask that if you do encounter a problem and need to contact support, do hold on to the request ID. These are returned with the error, actually with all responses, and this will allow you to communicate with support personnel about the problematic request, allowing us to look it up without having to exchange private information. Let's talk about the different types of errors that we're likely to encounter. Firstly, it's important to know that errors in Google Ads are organized into enumerations. So for example, I might have a quota error, that's the enumeration, and within that, a specific error, resource exhausted in this example. I can then use that information to go to the right reference page, because the reference pages are also organized by enumerations. Each enumeration contains details about the specific error. So if I encounter a date error, I can go to the date error page, and I'll be able to find all the possible date errors. In general, there are 4 types of errors that you could encounter when using Google Ads. These are authentication, retryable, validation, and sync errors. And we'll go over each of these in detail. Authentication errors, as the name implies, relates to permissions to access a Google Ads account. These are the sort of things that you're likely to encounter when you're first setting up your client library. As you do set it up, we strongly recommend running some of the simple included examples to test it out and tease out such issues. An authentication error might indicate there's a problem with your login credentials. Authorization errors might refer to you not having access to a particular feature. If you are encountering errors like these, we suggest that you first check the client library documentation to ensure that your configuration is correct. We do provide a tool called the Google Ads Doctor that can help diagnose authentication issues. You might also take a look at the guide pages for a particular feature. Some API features are gated behind allow lists. If you need access to any of these features, please reach out to your Google representative. Retriable errors indicate a temporary problem that hopefully can be resolved. Most Google Ads services do return an immediate response, but some resources might take time to be available. You should check documentation to see if a delay is expected for the feature you're trying to use. Some services, like batch processing, are handled asynchronously, so results will definitely not be available immediately. Remarketing lists are another good example. If you create a remarketing list, it takes time to populate and will not be available right away. To handle these errors, we suggest that you adjust your timeouts to something appropriate. More on timeouts later. You should retry your request with a back-off policy. Don't try to call it repeatedly until it passes. Definitely wait, otherwise you might run out of quota. The third type of error is validation, and these simply indicate that the input was not acceptable. This is very common with things like dates. Perhaps the date is in an incorrect format. If you encounter an error like this, check the dev site, ensure that you're populating fields with the appropriate values. Many fields are required and many are optional, so ensure that all the required fields are filled in. Lastly, when some kinds of errors are returned, you can drill down into them to see the underlying reason. For example, policy violation error contains a detailed reasoning as to which policy was tripped. Take a look at the handle policy violation error example in your client library for a detailed explanation for how to extract this information. Our last error type is the sync error. This commonly happens when you've stored some information locally, but it may no longer be consistent with information stored in Google Ads. This might happen if, say, you're sending a request using values from an out-of-date local cache or database. For example, maybe you're trying to modify an ad group that was recently removed. To address sync errors, use the API reporting services to get the current values from Google Ads. And once you have the current values, update your local storage and retry your request. We do provide 2 specific services, Change Status and Change Event, which are perfect for this need. They'll inform you as to which resources have changed within an account over a specified period of time. Change Status gives a summary of such changes, and Change Event gives the complete details of any changes down to the individual fields. So what does an error actually look like? A typical error response contains an error code, a message, a triggering value, and an object hierarchy. All client libraries return the same information, but implementation will be slightly different between them. Let's take apart my example error on the right to see each of these. First, we have an error code, which contains an enumeration, in this case campaign error, and the specific error, in this case duplicate campaign name. We get a message, a plain English description of the problem. This is actually the same message you'd see in the reference documentation on our developer site. Third, we have our triggering value. This is the exact value that caused the problem. So in this example, it was the string search space campaign space 1 that caused the problem. And lastly, we have a hierarchy of objects where we can find the problematic value. If we read this bottom to top, we can see that the problem was in the name field, the create operation, and that's the first element in the operations array. So to take it all in total, we can summarize this error as there was a problem with the campaign name search campaign 1. It already exists. It was supposed to be the name of the first new campaign created in our code. Knowing all this, I can hopefully go to my implementation and identify the offending code and trace its origins. I'd like to now turn to a live example. We'll put together a simple request to Google Ads API where we create an ad group with a specific name. We'll see that it'll work perfectly fine the first time, but if we were to run it again, we'd get a similar error to the one we saw in the previous slides about a duplicate name. So to summarize our workflow, we'll form the operation in request, we'll issue it twice, we'll catch any errors, and print any resulting details. For our purposes today, I'll be writing in C#. I'll be using JetBrains Writer IDE on Mac OS, but know that the same principles apply to all client library languages, and you should check our included examples for best practices with error catching in each library. I'll be writing all of today's code examples within the error handling directory of the Google Ads Examples project. This can be a convenient place for you to experiment with code or write small snippets before incorporating it into your official implementation. To take a quick tour through our starter code, I have a class called Basic Error Exemplar, and when run it expects a customer ID and a campaign ID to be supplied. We'll take this example to step through the normal Google Ads workflow. For those of you who are new with the library, this may be helpful just to see how we structure a call to a service. So, as I mentioned, we're going to be setting up a new ad group within our campaign, and we're going to give it a specific name. First thing we'll do is we'll set up the ad group service client, and we can easily load that up. That's the ad group service client type, and we can fetch that from our client. Again, there will be slight differences between the .NET library and other libraries, but the general pattern, general strategy will be the same. Okay. We'll then construct the new ad group that we want to apply. And this ad group, as I mentioned, will give a specific name. Remember, our goal here is to intentionally cause an error. So when we run this twice, it'll attempt to assign the same name. Simply set up an ad group object. And we're going to attach it to the campaign that was supplied as an argument. So we need to give a resource name here, and the libraries all have convenience helper methods that will construct resource names for you. In the case of .NET, it's resource names.campaign, and expects our customer ID and campaign ID. The only other piece of information I'm going to include here is the name that I'd like to apply to this ad group, and I'll give it the very helpful specific name, test ad group for basic error handling, and we're all set. The next thing we need to do is construct an operation, and this operation's job will be to create the new ad group. In general, operations can be one of three kinds. Either they're a create operation, a mutate operation to alter an existing resource, or a remove for you to obviously remove an existing resource. So we're going to apply a create here. And my operation is all set up. Last thing I'll need to do is set up the request. So we'll construct a mutate request. And there's an object for that too. This will be a mutate add group request. And all we need to supply here is our customer ID as a string. So we'll need to convert that in C#. And any operations that we wish to perform. Now, as I mentioned, we can send multiple operations in a single request. In this case, we're just going to send one. So I have an array with one element inside. All right. Now, I can execute this request by calling on my services mutate method, and I'll receive a response of a matching type. So I'm going to send a mutate add group request. I expect a mutate add group response to come back. I'll use the add group service clients mutate method, and I'll pass it the request that we already constructed. Okay. And lastly, I can maybe just print out a nice message to indicate that the request was processed. Okay. So there's my complete program for now. And again, this is the general template for working with Google Ads services. We need a client. We need some resource to work with. We need an operation. We need a request. And then we need to issue the request. And we'll receive a response. My run configuration here will just supply we'll call on this example and supplies a test customer ID and campaign ID. And I can run that. And we should see our request was processed message, indicating that it was indeed sent and received. Now, of course, I'm not actually testing the response yet, and we haven't seen if there's any error. But let me go and check my Google Ads account, and we can see that the ad group was created. So if I take a look at the campaign that I supplied, and I look at the ad groups tab, I can see that, yep, there is my test ad group for basic error handling that has been created. There's nothing in it, has no activity, of course, but it is present. Swapping back to Writer, let me try running this one more time, and let's see what happens. Again, the same code, nothing has changed, but now I have a non-zero exit status. Okay? Something went wrong during this request. And if I take a look at my ads account and reload it, then of course there's going to be the one occurrence of our test ad group and no additional. There it is. So what happened? Well, that's what we need to now catch the error so we can take it apart and see what actually went wrong. So let's add some try-catch logic to this request to see exactly what went wrong. I'm going to wrap my request and my processed message in a try block here. So we'll add that. And we're going to catch a Google Ads exception. Now again, this will differ slightly, the type of this error will differ slightly by library, and I suggest you take a look at the other examples in your library to see exactly what that pattern looks like for each. In my case, let's just write out our failure. Right, so we'll console.writeLine, there was a failure. And there's 3 pieces of information that I'm interested in printing. First thing, I'd like to see what the error message was. Right, again, this will be the plain text, plain English explanation of the problem. So that's the message feature. field, I should say. We will also print out the specific failure. Lastly, we'll also explicitly print out the request ID. And again, this is a unique identifier that if you ever need to contact any of our product experts, you can provide them with this request ID, and it will allow us to look up your request to diagnose any problems that you may be experiencing without having to exchange any private information. Okay, with that complete, let's go ahead and run it again. And I can see that now I have much more information. I can see that the request contained an invalid argument, and the specific error code was that this was an add group error, duplicate add group name. The add group with the same name already exists for the account. It was caused by the string test add group for basic error handling, which could be found at the first operation, which was a create operation, and within the name field. And finally, there's my request ID. You can see it's also contained in the failure message, but might be nice to call specific attention to it. So that shows how we can catch a specific error and report it out. Generally, we only need to catch errors that have to deal with requests. Anything that comes before that would just be local compilation problems. Let's move on to talking about partial failures. As I mentioned before, Google Ads API allows you to send multiple operations in a single request. Enabling partial failures means that any valid operations in a request that contains multiple operations will be committed, while errors will be returned for any operations that were invalid. It might be helpful to take a look at the structure of a request object. We'll use the mutate add groups request, just as we did in the previous code example. In this case, the request expects two required fields, customer ID and operations, and it has three optional fields, partial failure, validate only, and response content type. We're concerned with partial failure in this webinar, but for completion's sake, validate only will allow you to test a request without modifying any of your Google Ads resources, and the response content type will tell the API what sort of information you'd like returned. The default is just the resource name of the changed object. Let's have a look at an example array of operations. In this example, I have 4 operations bundled together in the request: 2 create operations, 1 mutate, and 1 remove. Now, it's important to note that the order of these operations does matter, because when I receive a response, the response will contain an array of results. The indices in the results array correspond to the indices of the operations in the request. So, since I issued 4 operations in my request, I received 4 individual results. In this case, the first 2 indices, 0 and 1, are my create operations, index 2 is my mutate, and index 3 is my remove. Note that the add group field in this example would only be populated if you set the response content type in the request. Otherwise, only the resource name would be populated. Now, if I were to enable partial failure, any individual operation that was not successful would return an empty response in the results array. So, a missing result indicates a partial failure. Other operations may have been executed, but not any that have an empty result. The message field partial failure error will contain information about the failed operations. They're actually organized in this message by the same indices we just discussed. So in my example, since my operation at index 1 was empty and therefore not successful, I'll be able to look up the reason it was not successful using index 1. Each client library provides a mechanism for doing exactly this lookup. We'll be looking at another example in C# in a moment, but do check your client library's handle partial failure example for guidance on how to extract these partial failure details. For this live example, we'll attempt to create two add groups with the same name in the same request. Now, since I expect to get a duplicate add group name error for the second operation, I'll need to implement partial failure handling to see that one was successful and one failed. So our workflow for this example, we'll start with the code from the previous example, we'll add a second operation, issue the request with partial failure enabled, and then detect any empty indices in our results. We'll look up any related partial failure error entries. We'll start by continuing from the previous code example. So as you can see, it's exactly as it was. We created the test add group for basic error handling, issued the request, and caught the error. Now, because we're going to be working with partial failures, we need to have more than one operation so that we can see the difference between a successful and a failed operation. So the first thing I'm going to do is I'm going to go down to where we create an add group operation. I'm going to rename this one add group operation 1, and I'm going to end up making a second operation. Now to do that, I'm going to need a second add group, which I'll add in just a moment. So we'll end up with two add group operations. The first one will create add group 1. The second one will create add group 2. Notice that now I have an error here. Let's correct that. My operations will be add group operation 1 and add group operation 2. Okay. So this time we'll send a request that contains two operations. We'll have those two operations. One will create add group 1, one will create add group 2. Let's create those add groups. And again, I want them to be pretty much the same. All right, we're going to attempt to create two add groups with the same name. Let's use a slightly different one. This is no longer basic error handling. This will be partial failure handling. And again, okay. So two add groups, both of the same name, both trying to be attached to the same campaign. Now, if I run this, I can see that we get an error. All right, let's see what actually happened in my ads account. If we reload my page, there's the add group for basic handling from before, and we'll take a look. And I can see that nothing was added. Okay, so if there is one failed operation in a request that contains multiple operations, then the entire set will fail to process. So this is, again, an important use case for partial failures. We want to be able to have the successful operations execute while the failed operations return an error. Let's take a look at how to do that. The first thing to do is to set the partial failure field on my request. We'll set that to true. And then we need to parse our response to see what actually was returned. Remember, we now have multiple operations that are included in this request, so we need to see if all of them were successful. To do so, we need to examine each result in the response to see if it was completed successfully. Okay, so I'm going to set up a quick loop for each. This is going to be each result in my collection of results contained in the response. It'll be mutate add group result, and I will call it mutate add group result. If that result comes back and it is empty or null, then we know that this particular operation, that the operation for this result did not complete successfully. Okay. It's going to also be useful for us to keep track of our indexes here. So I'm going to set up a simple integer variable to keep track of my operation indexes. We'll start that at 0. And we will increment that as we look at each operation. Okay. This way, I have a identifier, so I can print a message that explains which operation was unsuccessful. Operation index did not complete successfully. Give myself a little more room here for readability. And let's also print out some details. Great. Okay. We could also, we'll add some details in a moment. It might also be useful to print a message for completion's sake. We should indicate operations that did complete successfully. Succeeded. Great. Okay. So within this if, right, if we encountered an empty result, that must mean that the operation did not complete successfully. So now it's time to go through and see what the errors were in the partial failure message. So it's possible there may be more than one error here. There may be more than one error. So we're going to access a list of errors in the message. Again, this may the exact syntax for doing so will be different between each client library, but the principle is the same. And do take a look at the other examples in the error handling folder for the sort of canonical recommendation for how to read the partial failure message field. In the case of C#, though, I expect a list of Google Ads error objects. We'll call that errors. Not a new list. And I can fetch that from response.partialFailure. In our case, we have a get errors by operation index method. So there's my complete thing. I'll fix my imports, and there we go. Now, for each error, we'll print out its details. My collection is errors. I'm handling things of type Google Ads error, and we'll just call it error. Console.writeLine. A little formatting, just to make it nice and easy to read. Great. So there's our basic setup for looking through partial errors. Again, we're tracking things based on their index. So like we saw in the slide deck, we send our operations in an array, and we expect our response to contain a results array that matches those operations. So this index is a useful identifier for us to know which particular operation caused the problem. Let's run that now, and let's see what kind of result we get. Okay, so aside from my poor formatting, operation 0 did succeed, as we would expect. This is a new ad group name that we're adding. But operation 1 did not complete successfully. And there's the familiar error which we saw earlier. We have an add group error, duplicate add group name. And the problem, as we can see, was index 1 within my operations. The create, a create operation, and the name field was the problem. Okay. Notice also that we also have a valid exit code in this case. Some things were successful, some things did not, so exit 0 is appropriate here. If we take a look at the account, and let's reload this one more time, and we can now see that there is indeed test add group for partial failure handling. Again, no activity, of course, but there is exactly one occurrence of this, exactly as we would expect from one successful operation. For our last topic today, we'll turn to retry strategies and timeout settings. So each client library provides a 1-hour default HTTP timeout. That might be a bit long, so consider adjusting that to fit your needs. Each client library provides a mechanism for doing so. Take a look at the set custom client timeout example in each. Inevitably, though, you will need to retry some operations, some requests. So we want to share a few best practices for doing so. Firstly, we recommend using an exponential backoff strategy. For example, you might wait 5 seconds, then 10 seconds, then 20 seconds in between retries. This is just to ensure that you're not hitting the API repeatedly with requests that are simply not ready to be served yet. We want to make sure that there's a reasonable limit to your number of retries. If you continue to retry indefinitely, it may cause your application to appear to hang, leading to a bad experience for everybody. Also recommend that you update sparsely, meaning that you avoid sending many large objects at once. Consider instead sending fewer small objects, breaking large requests into several smaller ones, updating rather than recreating objects. That way these smaller operations are completed more quickly and you can get a more immediate response. If you don't need an immediate response, you might want to consider using the batch processing service. The batch processing service allows you to upload operations that will get processed asynchronously. So if you don't need a response right away, consider taking advantage of that. For our live example, we'll put together a backoff strategy. In this case, we need something that will be retriable, so we will take a look at adding a Google My Business feed to a customer. We'll assume that it's been created but is not quite ready yet and is therefore not yet available. So we'll begin by issuing a search query. If you haven't seen our reporting structure, this will be a good introduction to that. We'll check to see if there is any valid result return. If not, we'll delay. We'll build an exponential delay. And then we'll retry the query and check for any result. For this example, we'll assign a GMB feed resource name to work with. And again, we're going to start off by taking a quick look through the code that I already have here. I'm setting a feed resource name to work with just for the purpose of this example. We're getting the Google Ads service, creating a query. In this case, we're just going to see the status of my particular GMB feed. And then finally, we'll issue a paged request to check to see if that feed is actually available. To check the results, we'll see what the first result is. We're expecting only one item to be returned. And if it's null, that means it's unavailable. Otherwise, it must be ready, and we'll just kick back to wherever this was called from. Now notice this is currently, this request is currently set up in an infinite loop. Obviously not ideal, right? There's no restrictions to this, there's no delay of any sort. So if I were to run this now, it would just spam the API. God forbid I get, my access limited due to the spam, and certainly I would want to avoid using up all of my quota if I'm not on a standard token. So let's instead modify what's here already We'll first set a reasonable timeout down from the hour that is set by default. We'll set a 5-minute timeout, and then we will implement an exponential backoff strategy so that we're not spamming the API. We'll also set a reasonable number of attempts so that our application doesn't appear to hang indefinitely. So first thing we'll do is let's set up that timeout. To do so, at least in the .NET library, we're going to set up instances of the call settings object. And again, the procedure for doing this will be slightly different for each library. Check the set custom client timeouts example in each client library's examples folder. But the general idea is the same. I'm going to call this 5-minute timeout, so it's clear. And we'll set up the call settings. This will be call settings from expiration from timeout, and we'll set a time span from milliseconds and 5 times 60 times 1,000. Oops, 1,000 will get us 5 minutes. Great. To then use this timeout, new timeout, all I need to do is add it as an optional parameter in my request. So I'm going to add a third parameter here. In this case, I'm setting the call settings parameter, and I'll set it to 5-minute timeout. There we go. And that's it. That's all I need to do. Now any request that includes this call settings will have a 5-minute timeout. The procedure may be slightly different for a streaming request as well. So do check your client library examples to see any differences that may exist. Okay, now that that's done, I want to adjust this loop so it's not running infinitely and without delay. So to do that, as I mentioned before, we're going to set up an exponential backoff strategy. Okay, for that I'm going to need to keep track of 3 pieces of information. We'll need the number of attempts that we've made so far, and I'll start that at 0. We'll need a limit, right? And for the purposes of demonstration, I'll set that as a local variable with a value of 5. And lastly, I'll need to keep track of how long we have been sleeping, waiting, right, in between requests. So I'll start that at 0. Inside my loop now, I need to I'll add the number of attempts as a reporting. We can see how many attempts we've made so far. We'll test whether we've reached the maximum number of attempts, and we'll calculate a new sleep time each iteration. Let me first add the condition, right? Let me adjust my condition instead of an infinite loop here. Of course, now we have a limit to this. We'll set, and it will keep looping as long as number of attempts is less than my maximum. Okay, and then just because of the way this function, loop is set up, down here would be a great place to throw maybe an exception. If we do reach this point in the code, then we've exceeded the number of maximum attempts. So I can set a new status. How about status code deadline exceeded? Seems like a reasonable choice. And we'll pass on a message something like GMB feed is not ready after max attempts retries. Great. Okay, so next thing to do is adjust this if, right? If we do not have a valid row returned, then this is my indication that the feed is not yet ready. So this is a reasonable place to increment my number of attempts. I can remove this continue now. I will also adjust the amount of sleep time. So sleep seconds. Now, here's where the exponential part comes in. A reasonable way to handle this might be to multiply some reasonable amount of delay by a power of 2, something like that. but some sort of exponentiation so that we're waiting a longer amount of time with each individual delay. Okay. So in my case, I'm going to start with a base of 5 seconds, and I'll multiply that by 2 raised to the power of my number of attempts. So clearly 2 to the 0th is 1, so my initial delay will be exactly 5 seconds. The next delay will be 2 raised to the power of 1, so 5 times 2 is 10, then 2 raised to the power of 2, 5 times 4 is 20, and so on and so forth. I'll be sure to sleep for an appropriate amount for exactly that amount of time. Sleep seconds times 1,000. And let's print a nice message to inform the user of what's going on. I think I would like to tell them that we have checked num attempts times GMB feed is not yet ready. And then maybe an extra line. We are waiting sleep seconds before trying again. Great. So now we have a reasonable setup, right? We have a reasonable number of maximum attempts. We are incrementing, setting an exponentially increasing amount of time to wait, informing the user what's going on. Of course, we have our message, should the feed be ready? And we have some sort of exception that we throw if we are unable to get it within the number of maximum tries. So with this set up, let's give it a run. And I can see that, we checked 1 time, my GMB feed is not yet ready. And I realize now that I am incrementing num attempts in probably the wrong place. And we can see that it keeps going. Checked 1 time, checked 2 times, and so on and so forth. For your information, I created the GMB feed just before recording this example. And these sort of feeds can sometimes take several minutes, maybe an hour, a couple hours before they are ready. Again, there are certain types of features within Google Ads that require time in the back end to set up properly. GMB feeds are one of those. We can see that we're approaching 40 seconds and so on, and eventually, I won't make you all wait, that will time out. All right, just to bring it all together. A few key takeaways from today. We looked at navigating the error documentation in our dev site. We read and handled an error returned from the API. We took a look at enabling partial failures for a request that had multiple operations in it, reading that partial failure message. We took a look at setting reasonable timeouts and using an exponential backoff policy to handle any retriable errors. I'm hopeful that these steps have been useful to you and will prove useful to you as you get started with your implementation using Google Ads API. Of course, there's a variety of resources that can help you get going and that can hopefully provide the answers to many questions that you may have. In particular, I'd like to encourage you to reach out to us on the forum and our dedicated support email, where you can access, speak to experts to solve any specific issues that you may encounter. Thank you for joining me today, and I'd like to turn now to our Q&A session, and hopefully we can wrap up any outstanding issues that you may have.
All right. Well, thank you, Andrew. My name is Devin Chastanoff. I'm one of the developer relations engineers supporting the Google Ads API, and I'll be moderating the Q&A. First off, just want to thank Andrew, just because that was a fantastic workshop. So it looks like right now there aren't any questions, but the Q&A link is in the description of the YouTube event. So I'll give folks a few minutes and If anyone has any questions, feel free to add them, and we have a team of engineers on the line to answer any questions you might have. Okay, we'll just give it another minute or so, and if no one has any questions, that is okay as well, and we'll wrap things up. But I just want to give folks the opportunity to ask any questions that you might have. All right, going once, going twice. All right, well, looks like there are no questions from folks, but thank you all for tuning in. I hope you all learned a good amount from this webinar, and with that, I think we have our first question. So bear with me for just a second because I think I have the wrong Q&A session being presented, so just bear with me for a second. But the question that was posed is, for internal errors, how long should we wait? And what I'll do is I'll open this up to folks on my team to answer. The first question here, while I get the Q&A screen up and running. And folks on the Q&A, if you wouldn't mind just introducing yourself with your name and title before you give an answer, that'd be great. So the first question, just to repeat, was for internal errors, how long should we wait? Oh, sorry, I don't think they could hear me, but the question was for internal errors, how long should we wait? Someone on the team want to jump in there with an answer while I fix the screen here?
Hi, my name is Dessier. I'm a software engineer based in Mountain View. I think this is definitely nuanced depending on what like may be happening on the back end. So I think it's really hard to say. Here's sort of like the regular expectation that may have depending on the internal error that happens. Um, I feel like I would say like for these kind of situations that if you're running into a situation where you're regularly getting these sorts of errors, then I think that comes down that there's making sure that your uh deadlines are set appropriately, and I think this is probably something that's like communicating with our relations team on trying to figure out like what the root cause of it is and coming through a solution there. I want to see if does anyone else want to chime in and or have any other information they want to add to it as well.
Hi, I'm Josh Radcliffe. I'm a developer relations engineer in New York. Yeah, the only thing I'd add is if our systems deem those as retriable, like internally, you could, if you were using batch job service, it would retry those sorts of errors. But I'm not sure, I don't know off the top of my head if internal errors would be categorized that way during batch job processing.
Great, thank you, Destia and Josh. And just apologies if there's any background noise, one of the perils of working from home, as we're all managing. But let's move on to the next question here. We observed a performance issue from responsive search ads download, which caused a timeout. Is this something that should be expected?
Hi, this is Josh again. the first thing I'd ask is, I know it's hard to respond on this thing, but are you using streaming or paged search or search stream from Google Ads service? Because streaming is usually better if it's a particularly large result set. Although, yeah, it'd be helpful to know what exactly, at what stage you're getting the timeout, I guess. It's not expected that it would time out, but there's obviously lots of factors in there.
All right, well, we'll see if we get a follow-up on that. In the meantime, the next question is, are there any suggestions to handle the error array as a hash map instead, presumably instead of a list? Go ahead, Josh.
I think, I guess it's already, since your operations are, a list as well. So the key, I'm not sure what the key would be for the hash map, besides the index into your operations list. So that's why it's structured that way. I don't know if anyone else has a different interpretation of how that could be used.
I'm not sure there's a simple way to sort of represent the error as a hash map, since there's several nested fields in there. Um, so it essentially comes back as an RPC message, and then the client libraries have functionality built in to take that message apart.
Great, thank you. And that was Andrew. If you didn't recognize his voice from the presentation, looks like we have some new top questions here. What about sync errors? Not exactly sure what we're asking here. Maybe if you could provide another question with some more context, that would be helpful. But it looks like this is a follow-up to the question earlier. This one, we observed a performance issue from responsive search ads download. So the follow-up response was we used search stream to download responsive search ad data, and the performance is not good, caused a deadline exceeded error. We have time to retry and keep changing the deadline. What would be the suggested wait time?
Hi, this is Desi again. I think the question that I would have is what the sort of like what's the number of rows, like the amount of data that you're querying back. I think depending on the query that you're making, I think that could definitely impact what the deadline that you'll be getting back, or the sort of like how long it will take to process and actually return all the data for the request. And I think because of that, I think that it's hard to give an exact answer on what the sort of expected deadline would be, right? I think as a safe setting, right? I think setting the deadline for a little bit higher than what your I mean, this is there's two ways to look at this, right? Setting the deadline for a little bit higher than, I guess, like what your usual like safe request durations is, I think is fine. If there's a lot of deadline exceeded errors coming, I think that's something where we need to look at on a case by case basis to see like what's happening in those scenarios.
Yeah, this is Josh again. I'd also add, like, common reasons why this might happen, like a report that worked fine 6 months ago suddenly starts running into deadline errors, is if you have like a very wide date range, and that date range is just growing over time, like in the where clause of your query. Um, Lots of segment fields can also, make your result set much larger. So if it's the date thing, you could use some of the relative date ranges we have, like last 30 days, or because generally your data is not going to change beyond a certain window.
Great, thank you, Josh and Desier. I'm just going to scroll back up to the top. This is not related to error handling specifically, but a common question we get. Will there be a client library for Node.js? Maybe Josh, you can chime in here.
We do not have one currently. We have published our there are Bazel build rules that are published in GitHub. I'll see if I can track down the link to that, which you could use to generate the stubs for Node.js, but we don't have a full featured, a Node.js library with all of the bells and whistles.
Great, thank you. And it looks like we have one more question at the bottom here. Hi, Deliveroo team. Hi, I'm a marketing technologist at Deliveroo. We have a standard access and should have unlimited operations per day. Sometimes get a resource exhausted error. Is this expected?
Hi, this is Desi again. We do have various rate limiting that we do in general that like also for like service stability and things like that. So it's possible that may trigger as well for some requests. Doesn't mean that you don't actually have standard access. It just means that like maybe there could be something else happening with our services that have caused us to like some requests are being rate limited more than others just because, right? It has nothing to do with anything you're doing. So I think it's just something to be cognizant of, that sometimes like there may be some like some of these errors, like these resource exhausted errors happening, and it's not because of anything that you're doing. It's just something that is happening just to make sure that we're protecting like the stability of our services as well.
Terrific, thank you, Desier. I think with that, those are all the questions. If anyone has any additional questions, now is the last call. Another couple seconds. All right. Well, thank you everybody for tuning in and for these great questions. We really appreciate what you're thinking about and what sorts of issues we're running into. This really helps us as we work on improving the API continuously. So with that, I think we're going to end this webinar, but we look forward to seeing you all for the next one. All right. Thanks a lot, everyone, and take care.